Hey teachers, welcome back. This is Dr. Rosegrant, and we're going to talk a little bit about circuits, and specifically in this point in time, we're going to start off with simple circuits. Now for a simple circuit, all you really need is a battery, a bulb, and a wire. Now we're going to build up to that, and then we're going to lead into series and parallel circuits next. Now I don't use, when I'm doing my circuits, the basic circuit demonstrations, I don't use any of the holders, though it makes it easier to actually hold the wires and to see the results. What happens is that students start thinking that you need this as part of your circuit, which you actually don't. So for this part, no battery holders, no light bulb holders. We start with two wires, because what happens is students sometimes usually come into your classroom with a notion as to what circuits are. And so they know, like, oh, it's got to be in a circle and a loop. So with two wires, it's easy for them to, okay, well, I'm going to put a wire on either end, and then, sorry, I can't do it too well with one hand, but I come in, and what we do is we touch the bottom wire, and the one wire goes to the bottom of the light bulb, and the other wire goes to the side. And so this would light up. There we go. We can get it lighting up just a little bit. So with the two wires, this is how I would make the light bulb light up. And you can see how it kind of forms that circle. Now, the key part is understanding how the inside of a light bulb actually works. So you have the filaments, which are the two prongs of the coil, plus the part that's really tightly wound up, which is what gets bright. And because of the current is so high, creates light. But those two edges of the filament, one actually goes to the bottom of the bulb, whereas the second one actually goes to the side. Now when I'm teaching, I don't tell my students this right away. I want them to kind of play with it, because they'll start off with the tube, and they usually try to put it towards the bottom. And so what I do is I bring up a discussion that's like, well, what does the inside of a filament look like? And so if you have the light bulbs, after they burn out, the larger ones, what you can do is that you can actually break the glass, file down the edges, and actually let them see the inside of a light bulb, because a lot of your students never really have seen the inside of a light bulb. Or I draw it on the board, showing like, no, this is what it actually looks like. So once we get that done, we can finish up with the two wires. And if they get it to light up with two wires, what I do next is like, okay, I'm going to take one of these wires, I'm going to take it away. Now you need to make the light bulb light up with just one battery, one bulb, and one wire. And so again, we can still make a closed loop. I don't need that second wire to connect the light bulb to the battery, because I can put the bulb directly on the battery. And so what I can do is I can make a simple circuit in this fashion. So again, you notice that the wire is touching on the side. If I put it on the bottom here, it's not going to work, because again, the filaments, the wires on the side of the filament come to the side and the bottom. There's actually 4 different ways that you can do this. One of the most difficult things as a teacher, this is one of my toughest lessons, is because I need to let my students struggle. I can't have them, I want to show them the answer, I know it, but it's very challenging for them. So one of the things that I've found that helps also with the idea that in science, sometimes things that don't work is just as important, is in their journals. I can actually have them write down like, okay, we'll draw a picture of what didn't work, and let's start looking for patterns within what doesn't work and see, oh, what does work and what are the different things that work. And so I can introduce those drawings however they want to draw, but I can then segue later in my teaching if I get into schematics, that those rough outlines and those rough pictures of a circuit, we can actually create symbols for and turn it into schematics. So when I'm teaching, I start out this way. I don't talk about circuits, I don't talk about what they are, but I actually lead with these type of demonstration and hands-on activities so that I can get all of my students at the same spot with their knowledge as to what do I need for the basics of a circuit to work. So thank you, and have a wonderful day for listening.